Arvind Galgali sir. Hello, Arvind sir. Namaskara sir. Hello. Can I proceed, sir? Pasha.
Yes, sir.
Invitation share madu.
Yes, sir. Is it okay, sir?
Yeah. Full screen, madam. Make it full screen.
Sir, full screen ಆಯ್ತು sir ಈಗ.
ಹೌದಾ?
ಹಾ,
Okay.
ಈಗ sir?
Okay. Okay. Sridhar sir, can we start, sir?
Yes, sir. Please, sir.
Yeah. Very good afternoon. Overall, in the online class of this webinar. First, I welcome the eminent speaker, Engineer Anirudha Shah, AGM Technical, SK Steel, Bangalore. Sir, on behalf of Indian Concrete Institute and on behalf of SJB Institute of Technology, I welcome you, sir, for this webinar.
Thanks a lot, sir. Thanks a lot.
Yeah. I also welcome the principal of SJB Institute of Technology, Dr. KV Mahendra Prashant sir, and the head of the Department of Civil Engineering, Dr. Prasad CSME, and coordinator of Indian Concrete Student Chapter, Dr. R. Sridhar sir, and also all the faculty members of SJB Institute of Technology for taking an opportunity to organize this webinar. So on behalf of Indian Concrete Institute, I welcome you all. I also welcome all the members of Indian Concrete Institute and all MC members of Indian Concrete Bangalore Center for this webinar. I wholeheartedly welcome the today's delegates who are in the online. Okay, so I welcome you all for this webinar. Really, why we have to conduct these webinars? To share the experience of the industry persons. Okay, whatever the knowledge gained, so they will share with the young budding engineers. So by keeping in this mind, so the Indian Concrete Institute Bangalore Center has taken initiation to organize these type of webinars from the industry experts for all the 54 student chapter, IC student chapter of all the colleges. Okay, so with this, once again, I congratulate the Department of Civil Engineering, SJB Institute of Technology, headed by Dr. CSME Prasad sir, and his team taken this opportunity to organize this webinar. Once again, I thank you, sir, for organizing this webinar. I also thank the persons who are working behind to organize this webinar. So either directly or indirectly, once again, I welcome all those members who are well put to organize this webinar. Once again, I welcome the office bearers of ICI, Indian Bangalore Center, for giving an opportunity to organize webinar. So once again, I thank you all for organizing this webinar. Okay, over to Sridhar sir.
Good afternoon. I am Dr. R. Sridhar, Professor, Department of Civil Engineering, SJBIT, with the blessing of Sri Balaganganatha Swamiji, Sri Nirmananda Swamiji, and our Managing Director, Reverend Prakash Nath Swamiji. Today, we are the host along with the ICI Bangalore chapter for the technical talk on introduction to HYSD bars and understand the good and bad construction practices delivered by Engineer Anirudha Shah. On behalf of our institution, I welcome Dr. L.R. Manjunath, Chairman, Indian Concrete Institute, Bangalore Chapter, and Dr. Ramesh R.L., Secretary, ICI, Bangalore Chapter, for their immense support to conduct this seminar. I welcome our principal, Dr. K.V. Mahendra Prashant. I welcome our HOD, Dr. Prasad CSMME, faculty members, and participants gathered here. I heartily welcome today's speaker, Engineer Anirudha Shah, Assistant General Manager, Technical, SK Steel Tech, India. He completed his civil engineering graduation in the year 1992. He has experience in the steel and cement industry for more than 28 years. He worked with various reputed industries like Ultratech Cement Limited, Steel Authority of India, JSW Steel, and many more. Presently, he is working as AGM Technical, SK Steel Tech, India. I welcome you, Anirudha sir. Please
Thanks a lot, sir. Thanks a lot.
start your webinar, sir. Thank you.
Thanks a lot, sir. On behalf of SK Steel Tech Private Limited, brand name SK Super TMT, I welcome the principal, the HOD, and the entire faculty members of the HGB Institute of Technology, along with ICI, and we, on behalf of SK Steel Tech Private Limited, are very thankful that we are a part of the ICI team, and we are doing this type of webinars and seminars just to give a brief description about how steel is manufactured, what are the important aspects while purchasing the steel, and some good and bad construction practices which normally have to be taken care of. So once again, I welcome you all for this webinar, sir. Thanks a lot, sir. Now going ahead.
Please proceed, sir.
Sir, you can share your presentation file, sir.
Yeah, wait, sir, wait. I'll only share it, sir.
Yes, sir, you can share it, sir.
Yeah.
Yes, sir, fine.
Okay, sir. Thanks a lot. Just some years ago, I was just scrolling through the net and I got this very beautiful lines. Quality is never an accident. It is always the result of high intention, sincere effort, intelligent direction, and skillful execution. It represents the wise choice of many alternatives. Being a civil engineer and all those present in the today's webinars, they are the future engineers. Quality is a very important aspect. There are many things associated with quality, and that defines the age of the building or the structure. But it is not an accident, as said. It is the result of high intention, sincere effort, intelligent direction, and skillful execution. Being an engineer, your intentions have to be high, the effort has to be sincere. Being technical people, the direction and the execution has to be in the skillful and the intelligent way. A few of the population has all these things in one dish. So my request to you is that these 4 points will define the future of everybody. Going to the presentation now. Just a sec. Just a brief discussion about our company. Company is SK Steel Tech Private Limited. We are situated in Bangalore. Plant is in Dabaspet near Tumkur. We are manufacturing TMT or HYSD bars from grade 500 to grade 600. Presently, we are manufacturing IS graded billets conforming to IS code 2830 and with a commercial license number 4710051, and HYSD/TMT steel conforming to IS 1786/2008, the commercial license number 3433147. Now, why is TMT important in construction? As all of you are engineers and all of you know that concrete is very strong in compression, but very weak in tension. So a tensile member has to be provided to balance the compression and the tension. Plain concrete, as said, which is very strong in compression and weak in tension, and therefore does not prove to be a very good structural member by itself. However, it can be made extremely useful by reinforcing it with a material like TMT, which has the desired ductility, strength, and the bond characteristics. Why only TMT and why not any other iron products like steel, like angle channel plates, pipes, bars, and everything? Because compared to these products, the TMT has got a high bonding stress, bonding characteristics because of the ribs. It has a high amount of flexibility or ductility because of the elongation, and at last the strength also. So TMT is used widely in the RCC structures just to balance the compression and the tension, where concrete is weak in tension. The raw material which is used for manufacturing of TMT steel, first is the iron ore, which is a mineral which comes from the ground. In our area, the closest mines are in Bellary, to be precise, near Hospet. Now, iron ore, as I said, is a mineral which constitutes about 62.5 to 63% of pure iron. The rest 37%, it is the impurities. We cannot use the iron ore directly to manufacture steel. So this has to go through a process. It is called the sponge plant, where the iron ore is processed or refined to get sponge iron. Sponge iron basically is 99.5% pure iron, small balls of say 10 to 15 mm of diameter. Then the sponge iron is melted to get billets, and billet itself is a raw material for the TMT. So the basic raw material, if I start from the bottom, will be iron ore. Refining it, we get sponge iron. Melting the sponge iron, we get billet. And melting the billet, we get TMT. So this is a process. So this, for us, in the technical terms, if we say billet is the raw material for the manufacturing of the TMT. But to manufacture billets, we have to sponge iron. We have to have sponge iron, and to get sponge iron, we have to have iron ore. This is a small flow chart of how actually the steel is manufactured. The raw material goes for processing. It goes in the melting process. Then the impurities are removed from the molten iron by the ladle purging process. Then it goes to the billet casting machine. Once the billets are formed, it goes to the rolling mill, where you get the bars as per the size and the lengths. After that, it goes through a controlled quenching process where you get all the physical properties of TMT. Then self-tempering and normalizing process, cutting, packaging, and dispatch. I'll just go through one small video where the video is of our plant, where you can see how the steel is manufactured, right from the selection of the raw material till the packaging.
There is no sound, sir.
No sound, sir?
No, sir. Yeah, now it is fine, sir. No, sir.
ನಮಸ್ಕಾರ ಸರ್. ನಮಸ್ಕಾರ.
We all have just seen the manufacturing process. I'll go into detail of every process for you to understand. Hello.
Yes, sir. Yes, sir. Fine, sir. Audible, sir.
Okay. As engineers, like what I said while starting the presentation, was intention and quality. Quality is totally depend upon what and how you manufacture the product. There are very small aspects which are related to the manufacturing of TMT bars, and as a civil engineer, which you need to understand when you work on field. So I'll just start with the process explanation. First is the melting of raw materials. Now, sponge will come to plant from various sources. Some big people like JSW, SAIL, Tata, they have their own sponge plants uh, and the iron ore mines. But basically, the sponge which is present at plant is being lifted up with the help of a magnet. Before putting it into the melting process, a 5 kg sample of the sponge iron is taken. It is melted in a small 5 kg furnace, what we call in the technical terms. It is heated to a temperature of 1650 degrees, where the sponge iron melts and it becomes like lava. A small sample of iron is taken from that molten iron, and it is formed in the shape of a lollipop. That lollipop is put in a machine called spectrometer, which analyzes the chemical composition of the steel. Chemical composition is very important with respect to the durability of the steel, because it plays a vital role in the hardness, bendability, or the ductility, the corrosion which comes in the later part of the steel. So chemistry is very important to understand and to maintain. There are all put together 28 types of different types of alloys which are present in iron, out of which 3 are most important: carbon, sulfur, and phosphorus. This I'll discuss in the later stage. So first, at the raw material stage, the chemistry of the raw material is checked and ensured that it is as per the requirement. If in that 5 kg furnace, if there is a small bit of variation in the chemistry what we intend to have, that by by adding by adding some alloys, we get the perfect chemistry. Once the perfect chemistry is got, then the sponge iron goes to a big furnace which we have installed of 15 metric tons. The 15 metric tons of sponge iron is melted. It is basically like a bucket what you saw in the video. It is heated to a temperature of 1650 degrees. Again, this 15 metric tons sample, again a small sample is being taken, and again the chemistry is checked, because checking a 5 kilo sample and a 15-ton sample, there may be variation in the sponge which any plant procures. So once this 15 tons or one lot of steel, the chemistry is assured, then when it is come on the top, those impurities are removed from the core steel by the process is called as ladle purging. Now, what exactly happens in ladle purging is we insert gases from the bottom, Those gases bring all the impurities on the top, and those impurities we have to remove from the main product. These impurities are called as slag. This slag is used to manufacture cement. This slag can be used to fill grounds or to fill anything. So before going to the next process, the slag removal has to be done. Once this has been done, then it goes to the billet plant. All this is a continuous process. There is no different premises for each plant. It is in continuation. Then it goes to the billet manufacturing process. What happens in the billet manufacturing process? This molten iron at a temperature of 1650 degrees is put into a bucket, from where it has got two nozzles from below, beneath the bottom of the buckets, of the size of 100 mm by 100 mm or 115 by 115 mm. Normally for TMT, the billet size which are used are 100 by 100 and 115 by 115. The normal length is 2.44 meters, but depending upon the size of the bar to be manufactured, the billet length has to be adjusted for the minimal wastage of the steel. So once this billet starts to come out of that billet bucket, it comes in a long length, which has to be cut as per the the required lengths. Now at this stage, the temperature drops from 1650 degrees to 1100 to 1150 degrees. So when the billet is coming out of the bucket, you might have seen that the water is sprinkled on the billet just to cool down it and to bring it to the temperature of 1100 to 1150 degrees centigrade. All those who are present, I would like to tell you the most important factor in the manufacturing of steel is the temperature of the steel right from the manufacturing till the end. A drop of 50 degrees or a rise of 50 degrees in the entire manufacturing process can damage the steel to a very large extent. So the temperature control is so precise that a variation of plus minus 50 degrees is acceptable, but anything after that is practically not uh, not good for the steel, because it will create the hardness, it will create less ductility, the elongation automatically will come down. So the temperature of the steel, and at last the steel will be hard. So the temperature plays a very important role. Once these billets come out, they are cut as per the sizes what I told above, and then it goes to the rolling plant. Now the rolling plant consists of three different processes. The first one is the roughening stand, what we call in the technical language. The second is the intermediate stand, and third is the finishing stand. By seeing the video, you might have observed that the billets which are coming out, they are running in a continuous S form. So these S forms are called as the stands. Now, what exactly happens in the roughening stand is the billet is gradually the length of the billet is increased, the width and the height of the billet is decreased to get a tube form of billet. So suppose if one billet was 2.44 meters, then that billet can expand up till 50 meters, 60 meters, and in a tube form. So this roughening happens of the billet in the roughening stand. The second stand, which is the intermediate stand, the bars, these elongated billets or these tubular billets, they become in the shape of an egg-shaped billet, what we can say, and slowly in this process, they get the round shape. So that exactly happens in the roughening stage. In the intermediate stage. Once it becomes round, then it goes to the third stage, what we call it as the finishing stage. Here, you will get the ribs the name of the brand, the all what has to be embossed, and the ribs would be placed in this section. Now, up till here, the temperature of the bar from 1150 degrees in the billet process comes down to a temperature of 900 to 950 degrees centigrade. This all practically happens within a minute. This right from the billet when it comes out from the billet plant till the finishing uh, stand. The time taken is not more than 1 to 2 minutes. Now, I'll just give you one small example how the ribs are actually embossed on the bars. In my childhood or in your childhood, and now also you are seeing the sugarcane juice what we are getting in the market at the open place. Basically, there are two rollers. The sugarcane is put between the two rollers, and it is squeezed, and we get the juice. In the same process, like it has the grooves in it, the same grooves help in getting the ribs on the bar. So just to give a practical example to you, this we call it as the CNC rib cutting machine technically. Now, up till this process, the steel has got only the chemical properties and the hardness. Now, any TMT bar, if you take, this have to have, any TMT will have two types of properties. One is the physical property and one are the chemical properties. The chemical properties I have already told you about, but out of that only three, carbon, sulfur and phosphorus are very important. In physical properties, as per the IS code 1786 and 2008, it is that the elongation, the strength, the bend ribbon ability of that TMT bar, and the section weight. So officially, as per the IS code, these are the four properties of the steel or the TMT. Up till the finishing stage, we have got only the shape of the bar. It has not got a single physical property, and sorry, it has got the weight property of the TMT bar. But elongation, the bend ribbon ability, and the strength, we still have not got into the steel. Now, this is a very important process. This is called the quenching process. Here you will get all the properties of steel in one single unit. Now, what is the quenching process? I'll just tell you because it is too technical. I can't, actually, I'll not go into the details, but I'll just elaborate on some points. It's basically a tube of it's a round shaped pipe, as you can see in the picture. The bar is going through one end of the pipe. It comes out from the second end of the pipe. Water is sprayed on the bar from all sides with equal pressure, and the speed of the bar is maintained uniformly for the entire process. Now, what happens when these bars go inside that pipe, which is full of water? The temperature of the bar while going inside is about 900 to 950 degrees centigrade. Within a fraction of a second, I'm talking within a fraction of a second. Being in this industry for the last 18-19 years and working with big institutions, you can see the bar going inside from one side. You can't see the bar coming out from the quenching process at the same time. It comes within fraction of a second, and within a fraction of a second, the temperature of the bar is dropped from 950 degrees to 500 degrees within a fraction of a second. Now here, the water pressure and the speed of the bar plays a major role, like what I told you earlier. Now, once it comes out of the quenching box, now these bars go on a cooling bed. This is a cooling bed of our plant. It is 90 meters in length. The bar length is approximately 72 meters. And these bar comes on these cooling beds, and these bars are cooled from 500 degrees centigrade to the normal room temperature before it goes for the bending and the packaging process. Now, the elongation, the strength, and the bend and rebend ability of the steel all comes into these two processes, quenching and the natural cooling. Now, if you visit sites after this program, if you visit the sites and if you see bars, you will see three types of embossing on each bar at every 1 meter length. Some manufacturers are embossing TMT, some manufacturers are embossing TMX, and uh, some manufacturers are embossing QST. Now, people have a doubt whether all these three are the same or not. So I would like to specifically tell QMT, TMT, QST, and TMX are the same. TMT is thermomechanically treated, QST is quenched and self-tempered, and TMX is the name of the company called Thermax. It's a German company. This was the first company in the world to introduce this technology for manufacturing of the TMT bars. So those who have got licenses from Thermax, they are actually embossing TMX on it. But all these three names are the same and the process is the same. Now, what exactly happens to the bar from inside after the quenching and the self-tempering is this. If you cut any bar in the center, in the middle, if you polish the bar and if you put it in a chemical, you will get this, you will get these three type of rings to see in the bar. Every bar which is quenched properly and the temperature is maintained, you have to have these three types of rings. If you see the innermost and the biggest ring, which is white in color, that is giving the ductility to the steel, the bendability, the workability to the steel. The outer one, which is black in color, that will give you the hardness and the strength of the steel. And the center white line, which is a very thin line, will give both the ductility and the strength. Now, all those who are present here, with respect to steel, there are only 2 or 3 types of complaints which come normally from the market. And the first one is, sir, the steel is hard. The second one will be that the steel will be weight or overweight. These 2 complaints, what I have experienced, will come in from the market. Now, with respect to the complaint called hard, if these 3 rings, the center of all these 3 rings is not at one single point, these complaints will arise. If on one part of the bar, if you see the thickness of the hardness is more, and exactly cross opposite to that, the opposite side, if the thickness layer is less, the bar will crack while bending or the bar may break. So the most important while manufacturing of steel, or what we call is a good quality steel, the 3 ring center, the center of the 3 rings have to be at the same place. Now, coming down to the weight complaint, what I was talking about. See, when the bar goes through the CNC machines or where the ribs are embossed, the ribs on that CNC machine are cut by machines automatically in the plant. So what happens as the steel passes through those rollers, the diameter of that ribs or the diameter of the bar may get more because the continuous friction is there. So the weight complaint of overweight or underweight will come from there. But with respect to the cracking and breaking of the steel, the only thing what we have to keep in mind is the center of all these three rings have to be at one place. And the most important second thing is that the water which is sprayed inside the QST box, it has to be maintained, because if any one jet gets blocked and all these things happens, it is seen that the bar is not quenched equally from all sides. So this, we call it as the core of the TMT. Going to the next one, standards for TMT bars as per BIS code. Now, as for cement, concrete, the BIS code is IS 456/2000. For a TMT, it is 1786.2008. For all the civil engineers, these two codes are the Bibles of their day-to-day working. So the sizes available 8, 10, 12, 16, 25, and 32, which are generally used. Now some manufacturers have started to manufacture 14, 18, 22, 28, 36, 40, 44, and 48. But generally 8, 10, 12, 16, 20, 25, and 32 are used. The standard length of one bar as per the IS code is 12 meters and nothing less than that or nothing more than that. The grade of TMT which is used in the parts of, in this part of the country, especially Karnataka, if I say, is FE 500, 500D, 550, 550D, and FE 600. Now, what is D? D means, if I compare 500 to 500D, the 500D material has more of the ductility or more of the elongation compared to the FE 500. Now, what is FE 500 to understand? That is the strength of the steel for the load which the steel can take per mm square. When I joined this industry, it was 415, then 500 was launched, then 550 was launched. Now some manufacturers are giving 600. If we travel to northern India, 650 and 700 also have actually come into the market. But students understand one thing which is very important with respect to this grade of steel. As the grade increases, the ductility decreases. This is a very important aspect because we as manufacturers, when we started with 550 grade from, when we switched over to 550 grade from 500 grade, practically we were flooded with complaints. Sir, your bar is hard and we are not able to bend it that easily. It was bending, but with not that ease. The increase in the strength of the steel automatically will decrease the ductility of the steel. So more the grade, less will be the ductility. Physical properties, as I told, section weight, yield stress, elongation, and bend rebend test. So what is section weight? As per IS code, the standard weight of one bar per meter is mentioned in the red as what you are seeing. And one is the lower limit and one is the maximum limit. So any TMT manufacturer, as for say example, if I'm talking for 8 mm, if the steel is between 0.363 to 0.422, it is passed as per the IS code. But what normally the manufacturers prefer to manufacture the TMT is in between 0.363 to 0.395. Now, the weight of the steel plays a very important role in reducing the cost of the construction or the cost of the purchase of steel. I'll just give you one small example. Some manufacturers, they try to keep the weight just below the standard weight, and some manufacturers try to keep the weight of the bar just above the minimum weight. So how does it work practically? If I have to, if my bar bender or my engineer or my contractor tells me, sir, I need 1000 meters of 8 mm, for example. If I go to a shop and if the material is more of weight, automatically for that 1000 meters, the weight will be more. If it is on the lower side, but a bit above on the lower limitation, there you'll have to pay less because steel is brought in tons or in kgs and it is used in feet. This is a very important aspect when you are purchasing any TMT. Lower the weight, it will give you more the lengths, but lower the weight within the IS limits and not below the IS limits. We There are some manufacturers who are manufacturing at 0.35 also, but as far as it is failed steel. Coming down to the yield strength or the yield stress is the stress at which a material begins to deform plastically and will not return to its original shape when the applied stress is removed. I'll give you one simple example for this and for the elongation part. Now, when the steel is a tension member, but to check the elongation and the yield strength, we have to put it in a UTM. The force is applied and the steel is pulled. When we start, when we actually start pulling the steel till one limit, it is in the elastic stage. So what is exactly the elastic stage? When we start to apply the force up till a limit, the force is applied. If we release the force at that point, the steel will again come back to the original position. So that is called the elastic stage. Once more force is applied, it goes to the plastic stage. The plastic stage means the bar will elongate, but it will not come back to the original position. And the third and the final stage, this load applied to the maximum limit, the bar will break. That we call in the technical terms as the break-even point. While seeing the video, if you would have seen one thing very minutely, when the bar was put in the UTM machine and the force was applied, uh, a cup cone arrangement in the bar had formed. We call it officially the cup cone arrangement. Now that exactly is elongation, that exactly is the elastic stage. So the ultimate tensile stress is the maximum stress that the material can withstand while being pulled before breaking. So strength, if I want to talk in a very simple word, it is the ball point. The ball point should take minimum 550 newtons of load before it goes into the plastic stage and it breaks or it cracks, because one ball point is equal to approximately 1 mm square. The elongation, very easy to explain. Just do a small experiment with it. Just take a rubber band, uh, just measure the original length of the rubber band, just pull the rubber band up till the maximum pull. If you release that rubber band, it will come back to the original position. Now the difference between the original length and the pull length before breaking in terms of percentage is called elongation. Third is the bend ribbon test. This is a very simple test where we check the bendability of the steel, because when steel is used, it has to turn, it has to bend, it should not crack or it should not break. Here students, I would like to make one very important noting, because when I go to field, when I am meeting you people like you on the field, the experienced engineers, the owners, bar benders, contractors, whoever there on the field, uh, they try to tell her these all tests can be done on the field. Uh, Students, yield strength, elongation, bend, rebend. This test cannot be done on the field. These three tests have to be done in a lab only. Weight of material, you can check it on field also, because you have to just cut the bar, measure the bar, and you have to put it on a weighing scale. From there you can get. But yield strength, elongation, and especially bend, rebend, because normal what I have seen, no one on the field is, especially the bar benders, contractors, and the owners, they are not concerned with the yield strength and the elongation part. But yes, bend ribbon, they are concerned, because more the hard the steel is, the more the time it will take for a bar bender to bend it. So complaint will always come from the field, sir. See, I tried to bend your bar, the bar was this. But any steel, for all these four physical properties which have to be checked in the lab only. We can't do it on field. Only wait just to understand what it is, we can do it on field. This is a UTM machine. I am not going to this because your college may have this. In this, there are two types of UTM machines. One is the automatic one, and one is the semi-automatic one. To get the exact results, the automatic one is preferred. I'm not saying that semi-automatic is not accurate, but there you have to adjust all the dials and then we have to apply the load. So those reports may vary as per the load applied and as per the dial, the gauges set or the dial set. Automatic, you have to just place and just press on the button. It is completely done automatically. This is basically the computer print of the physical test. If you see on the right hand side, the tension test bar size is 10 mm. This typically is a graph how the steel reacts after putting pressure. If you just understand this graph very carefully, once I start to apply the load from 0, it goes at an angle of 80 degrees to a point. This point where it turns right from 0 to this point is the elastic stage. From where it turns right, again it goes in the horizontal pattern. It stops to one point and then it starts to go up. That is called the that is called the plastic stage. And the last one is the breaking point on the right hand side where the bar actually breaks after it cannot take more load. All this on the left hand side, what you all are seeing are the notings. Elongation of a bar plays a major role during earthquake. So more the elongation, more is the bendability, more is the flexibility of the bar to withstand an earthquake. Coming down to the chemical properties, carbon, sulfur, and phosphorus, like I told. See, carbon is alloy which gives the strength and the hardness to the steel. But if more carbon is there in the steel, it will increase the brittleness and it will reduce the weldability and ductility. So more the carbon, the less is the ductility. Those who all you must be having two-wheelers when you at your home. Two-wheeler bodies, the iron which is used in that to make the bodies, the shock absorbers, the main body and everything, those are high carbon steels. There you cannot use a low carbon steel. But when it comes to TMT, the carbon limit for Fe550 grade should not be more than 0.3. Then sulfur and phosphorus, these basically are the impurities in steel, which again have to be kept on the lower side, because these impurities are like the ignitions for it ignites the corrosion property of the steel. The corrosion, as you all know, or you will come to know in the future when you start working, is a very dangerous phenomenon in steel which nobody can stop. So more the sulfur and more the phosphorus, the corrosion is going to start very soon. This is a spectrometer, Belgium made. This is used to check the chemical composition, like what you saw in the video. A small sample of steel in the form of an what you call a lollipop is taken. It is just placed inside this. One arc comes on the surface of the on the surface of the steel, and within a fraction of a minute you are getting all the reports of the chemistry. I'll just show you a sample what we are doing at plant. See, there were 3 tests done. First was at 10:23, second was at 11:01, third one was at 11:38. The 1023 test was for the raw material, the 1101 was for the billet, and 1138 one was for the TMT. So if you see the time frame, within 1 hour 15 minutes, right from melting of the raw material, you are getting the finished products. And especially you just have a look on the percentage of carbon, sulfur, and phosphorus. It is changing at every level. At every 3 different levels, it has a different value. Why? The only reason that when molten steel or steel comes in contact with the oxygen while manufacturing, the percentage of carbon, sulfur, and phosphorus, they tend to change. In the initial part, in the raw material, you will get the least value. As you go towards the finished product, it will increase. So a good steel is that which has to be checked at these 3 intervals. For a customer, it is the end product, the TMT, which has to be done. But to get that, we have to go backwards and do these 2 tests, one at the billet level and one at the raw material level. And if you see in the bottom, in between zinc and carbon equivalent, you can see the percentage of iron. That TMT bar has 99, or that steel is having 99.108% of iron into it. As it goes to the next stages, the percentage of the iron is coming down, and the percentage of all these chemical elements are going up. This is a standard test certificate designed as per the guidelines laid down by the BIS. It has to have the ISI mark, commercial license number, to prepare the billets, and the TMT, name of the brand, to whom the material has gone, the TC number, the TC date on which the material, the TC number and the TC date are these 2 values when the steel is loaded or when it is built to a party. If you see on the left hand side, it is the bar size. Then next to the bar size is the bar weight per meter. Third one on the left hand side is the lot number. Now this lot number means one lot is equivalent to 15 tons, what we are keeping at our plant. If you go to the primary manufacturers like JSW, Tata, SAIL, Vizag, and RNF, their one lot is at least minimum 100 tons, because they have got a big furnace. So their lot will increase from 15 to 100. Next to that lot number is the quantity which is built, the date of testing. Every lot, when it was manufactured, the date has to come. Then is the chemical analysis: carbon, sulfur, phosphorus, and carbon equivalent. Then the mechanical properties like the yield stress, the ultimate yield stress, elongation, bend ribbon, and FE grade from which we are giving the material and the test certificate. If one small graph is on the right hand side, an official signature has to be there by the lab in here, the lab in charge at that point of time. So basically, this is a test certificate as per the BIS requirements. If anything is missing in this, then the manufacturer is playing games with the people. Purchasing the right TMT. If I want to buy the right TMT as a owner and I don't know what exactly is good steel, I have to keep these things into mind. They should be fixed in length, 12 meters. It should not be more or less, because random bars will result in the excess use of steel. ISI mark has to be present on every 1 meter of the bar length. Now this is compulsory as per the IS code. Every 1 meter will have the ISI mark. The grade of steel, the size of the bar also have to be present every 1 meter. This is as per the requirement of the government, as per the BIS code. Now one more they have introduced in the last 1 year. They have introduced one 6-digit code which comes every 6 meters of the bar. Means in one single bar of 12 meters, you will see these two digit codes. Now these six digit codes are divided into two parts. The first,
Sir,
yes, sir.
sir, PPT is not changeable.
So I have not, but sir, I am able to see this, sir. Purchasing the right TMT.
Yes, sir. It's okay, sir. Fine, sir. Fine.
So the first two numbers of that code is of the state code, and the four numbers after that two numbers is of the commercial license number what you have, the last four digits of that. This combined all together, six numbers you will find, one code every 6 meters or minimum twice in one bar length. Scaly bars, like bars which are having scales or small cuts, should be avoided. Rusty bars should be avoided. Zigzag bars, because while manufacturing, as I told earlier, when the temperature is not maintained, the bar becomes like snakes at some point of the time, and it normally becomes at the end. So these bars will not take the pressure uniformly. So zigzag bars have to be avoided while purchasing. This is a normal bar where you can see the ISMR. Here we are putting TMT. Many people, like what I told earlier, they are putting QST and TMX. The grid of the steel. This is just only for the sample which I am showing you. Now, understanding rusting and corrosion. When I was into the cement industry and when I stepped into the steel industry, when I started my career in the steel industry, when I went to the field, people used to talk and tell me, sir, your steel has corroded. It was red in color. It had a powder on the surface, and they used to tell, sir, the steel is not good because it is rusting or it is corroding. Now, as engineers, we have to understand the difference between rusting and corrosion. What exactly is rusting? Now, if you see the figure, what I am showing you, bars, if you keep open to the air, even if the bars don't come in contact with the bottom, the bars will try to become reddish, brick red color. A thin layer of iron will form on the bar, minute particles. If you rub your hand on these bars, that particles will touch your hand, it will get attached to your hands. But this typically is called the rusting of steel. But this is not a cause of concern or rejection of bars as per the PIS, because this rusting can be removed very easily. You just have to take a wire brush, you have to scrap that powder on that, and again you will get the jet black steel beneath that powder or that surface. So these bars only have to be cleaned and used. What is corrosion? Now, corrosion will never start on ground. Corrosion will start when the bar goes into concrete, and it will start after a long time. It may be 1 year, it may be 10 years, depending upon the climate, depending upon the bar quality, depending upon the concrete quality, depending upon the water which was used for the concreting. Because if you are using high alkaline water or high acidic water, the corrosion will start immediately. If the water is good, it is a potable water, what we call, it will start a bit down, a bit late. Corrosion has to be there. We cannot skip that, the entire process. Now, what exactly happens when the bar gets corroded? The first thing is the diameter of the bar. Suppose it's a 12 mm bar. Once the corrosion starts, the bar will lose its 12 mm diameter. It may become 11, it may become 10, it may become 11.5 also. Now, once the diameter of the bar reduces, the grip of the bar and the concrete will come down. The ductility, the bendability, or the pressure the bar can take under an earthquake will come down. The load taking capacity will also come down because the load is what it is the force per Newton mm square. Now mm square is the bar diameter or the bar area. So if the area comes down, the force will also come. It will not take that much of force. Corrosion is a very prominent factor in construction. We cannot avoid it. It can be avoided by using good water, a good quality of steel, which is less in carbon, sulfur, and phosphorus, by the use of cover blocks, the right amount of cover as per specified by the PS. By using all this, we compaction of concrete on one side, quality of sand and the aggregates, all this put together will make your structure durable. But corrosion, if I am not wrong, and what I've spoken with the engineers and my ex bosses told me that this is a process which no one in the world has stopped till now. But we need to understand the difference between corrosion and rusting. Tomorrow, if you go on site and see the steel is on the ground and it has become red, that steel can be used just by rubbing, as I told before. Sorry. Some good construction practices, steel should never be stored on the ground because like mud has acids into it. If it comes in contact with the steel and if the steel is there for a long time, the first process of rusting will start and it may go into the corrosion if it is kept for a very long time. So normally the steel should be kept 6 inches above the ground. You can put cement planks or cement poles or the wooden planks or wooden poles below the steel. If it is possible, cover the steel just to minimize the rusting. I am talking minimize the rusting. Nobody can stop the rusting. We are talking only to minimize the rusting. Cover blocks, they are supporting to reduce the corrosion. They cover blocks at regular intervals will give you the equal stress on the bars when the load comes from the top. And the last and the most important thing is they provide as an insulator from fire or heat. See, concrete is a bad conductor of heat. Now, if you don't put cover blocks and if the concrete members which have steel into it, if those steel members in the concrete members are exposed to the atmosphere, and if tomorrow the building catches fire, uh, the fire will attain a temperature of 3,000 degrees within a very short time. As it passes 1650 degrees, the steel inside the concrete will start to melt, and there is a chance the tension will be lessened and the structure may fall or it may develop some type of cracks which are not repairable. So concrete block cover blocks are used for this very purpose also, because by putting cover blocks, we are confident that the steel is embedded in the concrete. Even if the building tomorrow catches fire, the concrete being a bad conductor of heat, it will not pass that heat to the steel, and the balance between the compression and the tension will be maintained. And by the time that heat reaches to the steel, we have got time to call the fire tenders or to take the people outside the building. And when I was working with Steel of India Limited in their plant uh, as a junior quality head, we had done some test on cover blocks, and it's how it actually functions when we use them in the concrete structures. We have got, we don't have that much time, else I would have shared some details about it. Going to the next thing, what is the right amount of cover? See, in this, there are two factors. One is the normal conditions and one are the conditions which are extreme. The extreme conditions are the coastal areas. So in coastal areas, the covers will be more than the normal area. All these values could be found out in the IS code. Normally, for a higher grade, for a higher diameter of bar, say for say like 12 mm and 16 mm, the distance between two cover block have to be kept between 3 to 4 feet. It is not that you have to place it at every 2 feet. It's unnecessary wastage. But don't again put it at 6 feet or 8 feet because then it will not be useful. And for bars of 8 mm and 10 mm, we prefer it not more than 3 feet. This these figures what you are seeing is from my experience, personally my experience. What we used to do when we used to do the testing of the RCC. Coming down to one more aspect is the lapping of bars. Now in bars comes of 12 meters. Normally they are cut into two and they are used to bind the bars for a column. So what I have seen, if you go in the interiors, even in Bangalore, I had gone to one project in the morning. I was very near to your college only. I went to one project and I saw that this type of lapping was not done. This, in a typical civil engineering language, is called a joggle or an S-shaped lapping. If you see the top bar and the bottom bar, they are in one single line. If you see the verticality of both the bars, they are in one single line. Because if you lap the bars in this way, the load of the top bar will be distributed uniformly on the lower bar. One more figure I'll show you in the next part where you can come to know what I'm trying to tell you. Second, lapping of the bars should not be done above any slab or below any slab. This have to be done preferably in the center of the column between two slabs, because lapping zone is a weak zone and bottom and the, the portion of the column below the slab and above the slab is typically a weak zone. So if you do the lapping at that particular area, the structure will become weak. One more main aspect to this, if there minimum bars in column as per the IS code is 4. Some columns may have 8, 10, 12, 16, depending upon the size and the design. All bars should not be lapped at the same level. If you see the right hand side figure, 50% of the bars are lapped at one position and 50% of bars are lapped at a different level. The lapping of the bar should not be done at one single level. 85% of sites, they don't follow all these type of things. I'm talking with my experience. I'm not making any particular comment, but people don't follow. The reason behind this, I'll tell you. The normal height, what if you build your home, is 10 feet. The floor to floor height is 10 feet. Now, if the bar what you get in the market is 12 meters or which is 39 feet and 4 inches. If I cut it into two, it comes to 19 feet 9 inches. So if I try to lap the bar at the first slab, the lapping of the bar will come at the third slab. Just to save the wastage, many people are doing this type of work. But if you do in that way, you definitely are going to reduce the life of the building, because all these things play an important role when there is an earthquake. Hooks in rings. This also is not followed in many small projects. These are very important. after the Gujarat earthquake, if I am not wrong, there are many big professors in the meeting today. They can put more enlightenment on this. But what I understand, after the Gujarat earthquake in 1992, if I'm not wrong, this code was introduced and the rings have to have hooks. Now the length of the hook has to be 9 times the diameter of the bar. For 8 bar, it will be 7 to 10 or in very practical language, which is used on site, is 3 inches. The length of the hook starts from where the bar has been bent, and from where the bar becomes straight. And both sides, it has to be bent at 135 degrees. 135 degrees. These are very important aspects while the construction of any building, especially in the earthquake zone, because tomorrow if an earthquake happens, when the pressure comes on the concrete member, it may be column or beam, the corners try to break very easily. The main bars, they try to get away from that entire bond, but these hooks will keep them in the desired position. This what you call, I'm just, because in very simple long language I put it as L bars. Bottom bars and top bars of the beam have to be bent to up to 50 degree, up to 50% of the beam depth. This again is a very important aspect for in case of an earthquake. Normally, the bars are not bent; they are just in the horizontal portion. But these bars have to be bent up till 50% of the depth of the beam or slab, whatever it is. Curing of slab. Curing for any RCC structure has to be done for minimum 7 days, because any RCC structure to get its final for any concrete to get the final strength is minimum 28 days. But within 7 days the concrete has attained maximum limit of the strength. Now why curing is important? See, when I was in cement, when I joined cement in the year 93, that time the grade of the cement was 43. Then 53 came, then PPC has come. Now some manufacturers are even giving slag cement. As all of you know or might be knowing that cement, the raw material is lime. If you put your hand into a cement bag, you will feel like you're putting your hand into ice. But this cement, if mixed with water, and if you put your hand into that, and if you keep your hand in this cement, the pasting, the cement paste, only for 5 minutes, I'm talking only for 5 minutes, you take it out, all your hand surfaces will be cracked, because water when mixed with cement, it that cement, that material will start to give out the heat in that lime or in that cement. Now this heat, if it comes out with a very large pace and with a very large speed, that RCC member, it may be a beam, column, slab, any RCC member, it will lose its compressive strength. So the heat has to be put inside the concrete member. For that, the curing has to be started immediately. I'll just share one small example with you what I have gone through. When 53 grade was launched, we used to get complaints, sir, the plaster is cracking and the slabs are cracking. It was only small hairline cracks. But as 53 grade has more heat into it, the hydration process will be more. Now, what is an ideal thing to do? Suppose you are casting a slab of 1,000 square feet. Once you cast one portion of 10 feet by 10 feet and you go to the next portion, immediately start to sprinkle water on the portion which has been casted. Immediately, as
Anirudh sir, due to time limitation.
okay, sir. I'll just go. Gunny bags, these these are specifically used for the securing of concrete. It has to be kept wet in the daytime. Same for the staircase. Proper supporting to the RCC members while concreting, like slab beams, they have to be kept in a very vertical way. People normally don't do it. I'll share one photo after this. So props have to be vertical and not in slanting position. Some bad construction. Now see this figure. Lapping first is done at the wrong place. The position of the bottom bars, the position of the top bars, they are not aligned. The lapping is not done in the S form or in the joggle form. This is honeycombing, especially due to high water cement ratio, low water cement ratio, a poor compaction or more quantity of steel into the member. This is the first phase of corrosion. These are the types of supports what we are seeing normally in the market. They will be slanting at 45 degrees, 50 degrees, 60 degrees. And this is the end result of those type of supports. This photo I have actually clicked when I was on this slab in Belgaum. If the supports are not proper, if the props are not proper, while concreting, they may move out and make this type of holes into the slab. So any questions?
Participants, any questions are there? Please let us tell.
Good afternoon, sir. I'm Shailesh from Afcon Infrastructure.
Yeah.
Can you listen me, sir?
Yeah.
I'm audible.
Go ahead,
Okay,
please.
sir. And just I had a small question. Every time wherever we go for the billing purpose,
Yeah.
we estimate the quantity of steel in running meter.
Right.
While calculating that for the bend of 90 degree, there is 2D minus that we have to do.
Yes.
But we have nobody has given us a quite logical answer to why we have to do two diameter of bar deduction for those. Yes, we can understand using the mandrel according to specification. We have to use particular mandrel for the bending of bar for particular dia. But why we have to deduct 2D or 3D? Depends on diameter. How is to be how is to be estimated that for study purpose? You can elaborate on this. It will be
You
good.
only have given the answer because this question is unanswered till now. But I'll give you one simple logic what I understand.
Yes, sir.
Steel, when you pull, now when you are bending means you are pulling the steel. You are giving tension to that. So it has to expand. It will expand. Now when you are doing a 90 degrees turn with steel, the steel will expand, and that exactly 2D or 3D as per the bar size. Now it's not the bar size also, it is the mandrel size is also very important.
Yes, sir.
Talking about 2D, then the mandrel size accordingly will have to be set according to that. Now, as per the IS code, the mandrel size for bending is minimum 5D. But if you go on site, they will not use more than 2D, especially for the lower sizes.
Yes, sir. I do agree.
So that 2D or 3D is the extension of the bar when the force is applied to bend the bar. But the 2D and 3D, I will not go into the calculations because it will depend completely on the mandrel size.
Okay.
So it is the bar is expanding after the pull.
Okay.
So that is basically the reason for that, and nothing more than that.
Okay, sir. So, thank you. Thank you. Thank
Thank
you.
Okay, Anirudha sir, Anirudha Shah,
Yes,
for
sir.
your excellent presentation on this HYSD
Excuse
bar.
me, sir. Excuse me, sir. Sir, I have one question.
Yeah.
Sorry, sir. Sorry for interruption.
No issue.
Sir, is there any impact of slag cement on rebars?
Slag cement.
Yes, sir.
No. No cement has a direct impact on the bars. The
Okay.
water aggregates and the sand will have the impact on the bars. But cement will not have the impact on the bars. You're talking in terms of what? In terms of corrosion?
Means it is damaging. Yeah, it is damaging rebars in any sense.
No. Absolutely not.
Means compared to the conventional OPC cement which we are using.
No. Absolutely nothing like that. Absolutely nothing. The last information what I have.
Okay. Thank you, sir.
Thank you.
Okay, sir. Thank you, Anirudha Shah, sir,
Thank you,
Assistant
sir.
General Manager, for your excellent presentation.
Thank you.
I am thankful to Indian Concrete Institute also with hosting this webinar for our students and other participants. I'm thankful to management. Thank you to the participants who are all participated. Thank you, sir. Thank you very much for your kind presentation.
Thanks a lot, sir. Thanks a lot on behalf of my company, sir.
Thank you, sir.
Thank you.
Anirudh sir,
Thank you.
thank you very much for your kind attention for this program.
Thank you, sir. Thank you.
Give
Thank
your
you.
time,
Thank you.
precious time for us.
Thank you,
Yes,
sir.
sir.
Pasha, sir, thank you.
Sir, thank you, sir.